Okay, everybody, welcome to the review for exponential equations. So this is going to be similar to what you're going to see on the test, and I've broken this review into 3 parts. This first part is just going to talk about normal exponential equations. The next part is going to talk about exponential equations that have these fractions, and then the last part is going to talk about the solving the work analysis, the error analysis questions, which will be the 4th question on your test. Okay, so before I get started, when we are solving exponential equations, there are 4 general steps that we go through each time. The first step is to isolate the base. That means if there's anything outside this base, the side that has the base, like if I had a plus 5 over here, like a 13 to the x and then a plus 5, I would need to get rid of that 5 first by subtracting it to each side. Okay? That's what I mean when I say isolate the base. The next step is to get the same base on both sides. So the next step is to break the other side down so that it matches the base on whatever side your variable's on. Then once you have the same bases, you're going to drop the base and set the exponents equal to each other. And then after that, it should just be a normal equation and you would just solve it. Okay, so let's look at an example. So we're going to start on number 1 here. So number 1, I'm breaking this down to, there's nothing outside the base, right? So the next step is to break this down to a base of 13. And to do that, I use the factor tree. So I'm going to divide by 13 until I get to 13. So 28,561 divided by 13 is 2,197. So still not there. Divide by 13, and I get 169. Divide that by 13, and you get 13. That tells me how many 13s I would multiply by itself to get to this number. I have 1, 2, 3, 4 13s, so I could rewrite 28,561 as 13 to the 4th power, because there's 4 13s here. 13 to the x is equal to 13 to the 4th. Now, just to check this, one thing I always tell my classes is to type in 13 to the 4th, or whatever number you get, and make sure it actually matches this number you broke down. So you can see I got the same number, so 13 to the 4 is equivalent, and it's an easy substitute. Now, once the bases are the same, I'm going to drop the bases, get rid of the bases, just set the exponents equal to each other. And I should get x is equal to 4. And there's nothing left to solve here. There's no more equation, so I'm done. X is equal to 4. Okay? Same idea on this one. I have 3 to the 2x is equal to 3. So the base is already isolated. They're already at the same base. This has an exponent of 1, because if there's no exponent there, it's an exponent of 1. So I can drop the bases, set the exponents to each other. That gives me 1 equals 2x. And then to solve for x, I would actually divide by 2, right? Divide by 2. That gives me 1/2, or 0.5 is equal to x. And I'm done. Not too tough, right? Again, if I'm moving too quickly or anything like that, you can always rewind and watch me solve it again. Okay? Beauty of technology. Okay, this one, we have a base of 6, -6, technically. Now, again, when there is negatives, we basically just ignore them. We're going to treat it like a -1 multiplying with the 6. Okay? And we're going to do the same thing with this negative 7,000. So -1 multiplying with the 7,776. So we don't need to worry about the negatives. They're just going to go away anyway when we drop the base. So the point is to basically see how many times 6 goes into 7,776. So we're going to divide it by 6 until we get to 6. So 7,776 divided by 6 is 1,296. So still not there. Divide by 6, and I get 216. Divide by 6, and I get 36. Oops. And divide by 6, and I get 6. Okay. Now, I can count up how many 6s I have. 1, 2, 3, 4, 5 6s. So that means 7,776 can be written as 6 to the 5th. Again, double checking, 6 to the 5th power is in fact 7,776. So I can rewrite that as -6 to the x equals -6 to the 5th. Okay, and then I have the same base. I'm going to drop the bases, set the exponents equal to each other. I get x is equal to 5. And that's my answer. Okay, pretty simple problem so far. Let's see if we can get a more complicated one. So looking at this one, my base is not isolated, right? So the very first thing I need to do is I need to actually move this 5 to the other side. So I'm going to subtract 5 to each side. That gives me 9 to the 3x minus 4 is equal to 81. Now the next step is to get the same base on both sides. So I got to break this 81 down to a base of 9. So I'm going to divide by 9, and I get 9, which means 9 goes into 81 2 times. So I could rewrite 81 as 9 to the second power, and that's still equal to 9 to the 3x minus 4. Now 9 to the second should be one that you guys kind of all know, but again, if I'm double checking, 9 to the second is 81. Okay? Now I have the same base on each side. I'm going to drop the bases, set the exponents equal to each other. That's going to give me 3x minus 4 is equal to 2. Now it's just a party problem, two-step equation, right? So I'm going to get rid of the add first, or the subtract. So I'm going to add 4 to each side. That gives me 3x is equal to 6. I'm going to get rid of the multiplying best friend here, so divide by 3, and that gives me x is equal to 2. And that is my answer there, right? So x is equal to 2. Oh, I missed one. One more, number 5. So this one is a trickier one and involves one of our properties, right? This, anytime you see 1, you know that any number raised to the 0 power is 1. So I can replace any 1 I see with some number raised to the 0 power. So if I want to get to the same base, I'm just going to change out that 1 for 2 to the 0 power, because that is going to equal 1, right? So that's an equivalent easy substitution. And now they have the same base, so I drop the base, set the exponents equal to each other. 9x is equal to 0, divide by 9. Nothing divided 9 times is still nothing, so x is equal to 0. Okay, a couple more problems on the back here. Let's see, let's do number 8. So on this one, we're trying to get to a base of 5. So we're going to divide 15,625 by 5 until we get to 5. So 15,625 divided by 5 is 3,125. Divided by 5 is 625. Divided by 5 is 125. Divided by 5 is 25. Divided by 5 is 5. Okay, so looking at that, I have 1, 2, 3, 4, 5, 6 5s. And just to double check, 5 to the 6th power is 15,625. So I can rewrite that as 5 to the 6th power equals 5 to the 2x. Now they have the same base, drop the base, set the exponents equal to each other, gives me 6 is equal to 2x. And then I would divide by 2. And that gives me 3 is equal to x. And I'm done. Okay. And then, let's see. Let's look at this one. So on this one, 8 to the negative x is equal to 512. I'm trying to get it to a base of 8. So divide by 8. 512 divided by 8 is 64. Still not there. Divide by 8. I get 8. I have 1, 2, 3, 8. So I can rewrite 512 as 8 to the 3rd. Just to double check here. 8 to the 3rd is 512. So that gives me 8 to the negative x is equal to 8 to the 3rd. Have the same base. Going to drop the bases, set the exponents equal to each other. Get negative x is equal to 3. Get rid of that negative by dividing by negative 1. And x is going to equal negative 3. Okay. Not too bad so far, right? Last one for this video. We're going to do number 12. So number 12, I have 7 minus x, or 12 to the 7 minus x equals 1. Again, anytime I see 1, I can replace that with 12 to, or any number to the 0 power, right? So I could rewrite this equation as 12 to the 7 minus x is equal to 12 to the 0. Now they have the same base. Going to drop the base, set the exponents equal to each other. Gives me 7 minus x is equal to 0. Minus the 7 gives me negative x is equal to negative 7. Divide by the negative 1, and x is equal to 7. And that is my answer. Again, that's going over all the normal exponential stuff. If you're struggling with the fraction stuff, go to the next video. That's where I go over those fraction problems.